Dear students, I, Mr. Vishal Shaha, Assistant Professor, Christian Institute of Pharmacy, Karad, once again welcome you all to this another session of the chapter Fats and Oils. As you know, here we are going to discuss about the analytical constants of fats and oils. Already in previous video, I have started with the one of the analytical constant that is known as the iodine value. In previous video, we have discussed about the one of the method that is used for the determination of iodine value, that is the iodine monochloride method. In this video, we are going to discuss about the second method by which we can determine the iodine value, that is the iodine monobromide method, which is similar to the iodine monochloride method also. Also, principle involved in these two methods is same. So in short, we have discussed about the principle in the previous video. If you have not watched my previous video, then I request you can watch my previous video. Also, if you like the content of this particular channel, then you can share and like my YouTube channel. Also, in this video, we are going to see the in detail principle involved in the both the methods, that is the method iodine monochloride as well as the iodine monobromide method. So let's begin with our today's session. Before that, just we will see what are the learning outcomes of this session, means what you can understand by watching this particular video. After this session, students will be able to explain the analytical constants used for the determination of various oil constants. We have discussed various analytical constants like acid value, saponification value, iodine value, as well as the acetic value. So these are the various analytical constants. In this video, as I said, we are focusing on the iodine value. Now, before discussing with the iodine monobromide method, just I will revise what is the meaning of iodine value. Iodine value is defined as number of grams of iodine that are absorbed by the 100 gram of fat or oil sample. So here iodine value will give us a indication or the idea about the unsaturated character of that our fat or oil sample. So it depends upon the number of double or triple bonds that are present in the given fat and oil sample. Now, as we know, if we go in detail about the structure of the fat or oil sample, we know that fat or oil sample is basically consisting of two components. One is the glycerol, which is known as the alcoholic portion, other one is the free fatty acids. Now, normally these free fatty acids are consisting of, or you can say these free fatty acids are of two types. One is the saturated free fatty acid or another one is the unsaturated free fatty acid. These free fatty acids, like unsaturated free fatty acids, they are consisting of the double bonds, and saturated free fatty acids are not consisting of the double bond. So depending upon the presence of saturated free fatty acids or unsaturated free fatty acids, there might be saturated fat or fats may be present or unsaturated fats may be present. So iodine value will give or differentiate between these types of the saturated and unsaturated compounds, because iodine will be absorbed by only unsaturated fatty acids and saturated fatty acids does not react with the iodine. As iodine is very slow in terms of reaction, that's why we are going to use the iodine monobromide or iodine monochloride for the determination of the iodine value. So as I basically said in previous video also, these both methods are based upon the oxidation reduction type of titration, in which iodometry type of titration is involved. Basically both the methods only involve the difference that in iodine monochloride method we are going to use the iodine monochloride as a reagent, and in case of iodine monobromide method we are going to use the iodine monobromide as a reagent. Iodine monochloride method is also known as the Witch method, while iodine monobromide method is known as the heinous method. Now, as I said, basically this particular method is based upon the following chemical reaction. Here also the reaction involved is same, which already we have discussed in the iodine monochloride method, where you can see that if our fat or oil sample which is consisting of the unsaturated free fatty acid, then definitely they will be consisting of such type of carbon-carbon unsaturated double bond. So when such a sample is first reacted with the iodine monobromide solution, due to which what happens, as the reactivity of iodine monobromide is more, due to which one atom of the iodine will be attached to the one carbon atom and another atom of bromine will be attached to the another carbon atom, which leads into the formation of a carbon-carbon single covalent bond. So here oil or fat sample is converted into the halogenated fat or oil sample. So in this first method, what we are going to do, our fat and oil sample is reacted with the iodine monobromide method. Similarly, in iodine monochloride method, instead of IBR, we are going to use the ICl, which is known as the iodine monochloride solution. So this is the basic step, that is the first step. Now, how oxidation reduction reaction is carried out over here? As I said, in this reaction, we are going to use the iodometry type of titration, where iodine is liberated between the reaction of our sample and the potassium iodide, due to which here potassium iodide is acting as a reducing agent, while our halogenated sample is acting as a oxidizing agent. And due to the reaction between potassium iodide and our sample, there will be liberation of iodine will takes place. And if liberation of iodine takes place, and if this liberated iodine is reacted with our standard reducing agents like sodium thiosulfate, these types of titrations are known as the iodometry type of titration. All iodometry type of titration involves the sodium thiosulfate as a reducing agent. Now here iodine is liberated because the excess amount of iodine monobromide that we have used. Here you can remember that in first step we are going to use the excess amount of iodine monobromide, because what happens, say for example, if we are going to use the 50 ml of iodine monobromide, out of the 50 ml of iodine monobromide, say for example half, that is the 25 ml of iodine monobromide is reacted, or it is required to react with our fat and oil sample, so that it will carry out the conversion of all the unsaturated bonds into the saturated single covalent bond. And now remaining amount of our iodine monobromide will react with this particular potassium iodide. So remaining amount that we have used is reacting with the potassium iodide. And due to the reaction between iodine monobromide and the potassium iodide, here iodine monobromide is acting as an oxidizing agent, while potassium iodide is acting as a reducing agent. So liberation of iodine takes place due to the reaction between the iodine monobromide and the potassium iodide. In this reaction, as I said, iodine monobromide is acting as an oxidizing agent and potassium iodide is acting as a reducing agent. Now further, oxidation of iodine ions and reduction of the iodine monobromide will takes place. After this, whatever the amount of iodine is liberated, as we know iodine is acting as a oxidizing agent, that liberated iodine in acidic condition is reacted with the sodium thiosulfate, and here sodium thiosulfate is acting as the reducing agent. In this case, iodine will be oxidized and sodium thiosulfate will be gets reduced to the sodium tetrathionate. So this is the basis on which the iodine monobromide method is used, which is known as the iodometry type of titration. So this is about the principle involved in the iodine monobromide as well as the iodine monochloride method. Now depending upon the amount of sodium thiosulfate that is consumed by using the formula, we can carry out the calculations or we can determine the iodine value. Now you can remember that here in this case we are going to use the starch as our indicator. Now what is the role of starch? Now iodine, when reacted with this starch, it will form a blue complex, because due to the presence of the amylopectin and amylose, amylopectin will form a deep blue color with the starch. Now initially our solution is consisting of the iodine. So when we add the starch at towards the end of titration, because this iodine starch complex is little stable, that's why always in iodometric type of titration we are going to carry out the addition of starch indicator towards the end of titration. So first, initially starch will form the blue colored complex with our iodine. As soon as liberated iodine is going to react with the sodium thiosulfate, this iodine will be converted into its reduced form, that is the iodide ions, so that as soon as there is a complete reaction of iodine with the sodium thiosulfate takes place, further extra addition of sodium thiosulfate, because no iodine is present, due to which iodine and starch complex will be broken down, and from blue to we will get the colorless color, and depending upon this we can judge the end point of this particular solution. That's why starch is used as the indicator in these types of the iodometric type of titration. Now actually we will see what is the procedure involved in this particular iodine monobromide method. Dissolve about 1 gram of accurately weighed sample in dry 500 ml or 250 ml iodine flask. We have to add 20 to 25 ml of chloroform, or we can use carbon tetrachloride and dissolve. Here this chloroform and carbon tetrachloride is used for dissolving our sample. Now add slowly with the help of the burette 25 ml of iodine monobromide solution. Insert the stopper and allow it to stand for the 30 minutes. Why we have to stand this particular sample in both the methods for 15 to 30 minutes? Because we have to allow the reaction of iodine monochloride or iodine monobromide towards our sample, because the reaction is quite slow. Once complete reaction is taking place, excess amount of iodine monochloride will remain as it is in our solution. Now we are going to add the 20 to 40 ml of potassium iodide solution and 100 ml of water. Now due to the addition of potassium iodide, the iodine monobromide will react with the potassium iodide, which leads into the liberation of iodine. And this liberated iodine is acts as the oxidizing agent, and this liberated iodine is titrated with the 0.1 molar sodium thiosulfate using starch solution, which is added towards the end of the titration as an indicator. So this is very important. So once initially our solution is having about the brownish color, so we have to titrate until the solution becomes yellowish. Then we have to carry out the addition of the starch. This is nothing but the starch is added towards the end of the titration. Then we have to take both the readings with sample and without sample, and then we have to calculate this particular iodine value. So these are the various presumed iodine values are there. If our quantity of the substance is 1 gram, it will be less than 20. If it is 21 to 60, then it will be between 0.25 to 5. If it is 61 to 100, then it will be 0.15 to 0.25. If sample is more than 100, then if the iodine value will be more than 100 if the sample is 0.1 to 0.15. So this is about the second method, the iodine monobromide method. So this is the exercise for you. Go towards this particular website. By using passcode, you can give the answer for the question. Thank you. If you like the content, You can share and subscribe.